Hi guys! Today we're going to talk about how we can use factoring to solve a quadratic equation. Now, unlike a linear equation where we do things to both sides, multiply both sides by 2, subtract both sides by 8 or something like that, you can't solve a quadratic that way. Okay, so we use the zero product property, which means anything multiplied by 0 is 0. Okay, let's build up to what that means for us in quadratics. Okay, so I'm going to start very simplistically. Okay, 0 times 5, easy, 0. 0 times x, you don't even have to know what the number is. Anything times 0 is 0. Okay, if I distribute a 0, that's 0 times x and 0 times 2, and all of that still makes a 0. 3 take away 0 is a 0, and if I distribute that, I get the same thing I did before. Here's where we're getting into the idea of this. Notice that on the right hand side we have x minus 5, and what the left hand side would have looked like is x minus 3. We're using the fact that a positive 3 subtracting 3 would make this whole factor a 0. Distributing a 0 makes the answer 0. So if the equation equals 0, we're just trying to figure out what numbers make the equation 0 out. Okay? So to solve a quadratic by factoring, you want to make sure the quadratic is set equal to 0. Then you're going to factor the quadratic. You're going to set each factor equal to 0 and solve for the variable twice. Now, disclaimer, not every quadratic is factorable. So we're going to have other strategies for solving quadratics besides factoring. Okay, so we have our first example. We have x squared minus 8x plus 12, and the important part is that it equals 0. If our quadratic is not in that form, we have to make it in that form. All right, so we're going to factor this. All right, we've got a plus sign in front of the 12. That tells us the signs are the same. A minus sign in front of the 8 means they're both minuses. And I need two numbers that multiply to make 12 and add to make 8. So 2 and 6 work. Now, what I'm trying to figure out is what numbers would go here or here in order to make a 0 for us to distribute. So if I put a positive 2 in the place of this x, then the first factor zeroes out for me to distribute into the second factor. So one of my solutions is x equals 2. In my second factor, if I put a positive 6 here, then the second factor would zero out to distribute with the first one, and I would also get a 0. So there's two solutions. You can see your solutions if you look at the graph on your calculator. You can see the positive 2 right here and the positive 6 right here. So that's a good little check for yourself to see if you factored it correctly. Okay, so the factors will be the numbers that you see on the graph, the 2 and the 6. Inside the parentheses is going to be the opposite signs, minus 2, minus 6. The answers will be the same as the graph. Okay, our next one. A minus sign in front of the 24 indicates that one of my signs is a plus, one of my signs is a minus. I could have switched those. The important part is where I'm going to put the numbers. So I need numbers that multiply to 24 and subtract to 5. Okay, so let's see, 1 times 24, nope. 2 times 12, nope. 3 times 8, there we go. Okay, so 8 is the larger one. It's going to go to the same sign as the 5, and 3 goes to the other. So for solutions, I need to know what value of x will zero out a plus 3. Well, a negative 3 zeroes out a plus 3. And a positive 8 will zero out a minus 8. So those are my two solutions. And again, you can see the solutions on the graph. The solutions will be the numbers that are the same signs, and the factors will have opposite signs. So like this crosses at negative 3. Negative 3 is the solution, plus 3 is in the factor. Positive 8 is a solution, minus 8 is in the factor. If your quadratic starts out with a negative sign, you're going to want to factor that out before you factor into two binomials. So I'm going to factor the negative sign out. All that does, remember, is change the sign. So negative x squared becomes positive x squared. Minus 10x becomes plus 10x. Plus 75 becomes minus 75 equals 0. Now I will continue to carry that minus sign down, that negative sign down. Okay, I need, let's see, a minus sign is indicating that my signs are different. I need two numbers that multiply to 75 and subtract to 10. So that would be 5 and 15. The 15 being the larger number will go to the plus, and the 5 will go to the minus. And for solutions, x is going to be negative 15. Oops. And x is going to be 5. Okay, now I just want to reiterate, the negative sign is factored out. We don't have to think about it anymore. It doesn't impact our solutions. All it did was pull out of the original equation. Okay, if a is greater than 1, and a doesn't factor out, like we can't factor the 3 out, okay, then we have to use our strategy of either guess and check, or I don't like guess and check, I like the procedure that I taught you guys. So 3 times 7 is 21. And I need two numbers that multiply to 21 and add to negative 22. So a negative 1 times a negative 21 will give us a negative 22 in the middle. So we'll have 3x squared minus 1x minus 21x. Bring down our plus 7 and our equals 0. Then we're going to split this up. So in the first part, I can factor out an x. I'd be left with 3x minus 1. There's a subtraction sign here. If you have a subtraction, you want to factor out something negative. So I'm going to factor out in negative 7. That'll give me 3x. Positive 7 divided by negative 7 would be a minus 1. And I know I did this correctly because 3x minus 1, 3x minus 1, they match. They have to match. Okay, then I will take the x and the minus 7, and that's one of my factors. And 3x minus 1 is my other factor. and that equals 0. Here's where solve twice kind of comes into play. X minus 7, x would have to be a positive 7 to get that to 0 out. 3x minus 1, it's not as simple when we have a coefficient here to just, say, okay, 3x minus 1, so positive 1? No, that's not the solution. Okay, 3x minus 1 equals 0. If I change sides, I change signs, so I'm just going to move the 1 over. 3x equals 1. Divide by 3, and x equals 1/3, and that's my other solution. But because x had a coefficient in that factor, it just involves a little bit more work. And one more example, we've got this quadratic, 8x squared plus 2x minus 21 equals 0. 8 times 21 is negative 168. Now, I use the calculator hack to help me figure out what factors to use. The factors that I need that will make a positive 2x in the middle would be plus 14 and minus 12. And again, we split this. So let's see, 2 and x divide out of the first one, leaving me with 4x plus 7. A negative 3 divides out of the second one, leaving me with a positive 4x and a plus 7. Factors will be 2x minus 3 and 4x plus 7. Now both of those factors have coefficients, so I'm going to have to set up two equations. And my advice is don't try to do these in your head, because every time I do, I get the fraction upside down or I get the sign wrong. I make myself write them. Now, I will tell you that I don't always write down, like I didn't write down the add 3 to both sides, okay? And I don't always write the divide by 2 on both sides, okay? But I at least make myself write down those steps so that I don't mess up with a sign or whether the fraction goes right side up or upside down. So 3/2, same thing as 1.5, either one. Here again, I'm not going to actually write subtract by 7 on both sides because I'm starting with 0. And my other solution is negative 7/4. I would probably leave that solution as a fraction if possible, because it's going to divide out to be a 6-digit repeating decimal. No, that's a lie. I'm thinking of dividing by 7. Just kidding. That is going to be, you can leave them as fractions if you want. Negative 7 divided by 4 is negative 1.75. But either way. Okay, so this quadratic is not set equal to 0, it's equal to negative 7. So in order to make this something we can solve, we have to set it equal to 0 by adding 7 to both sides. So x squared plus 8x plus 7 equals 0. Now this is something we can factor. Plus in front of the 7 means the signs are the same. Plus in front of the 8 means they're both plus. 1 and 7 multiply to 7 and add up to 8. And I get solutions of x equals -1 and -7. Sometimes you might be asked, what are the zeros or the roots of a function? Remember that zeros and roots of a function are the exact same thing as solutions to the equation. In other words, if I said 0 equals 3x squared plus 6x minus 45, that is the equation, this is the function. Okay, and what they have in common is the solutions to the equation are the zeros of the function. They're the same numbers. Okay, so what we would be doing then is factoring in the same way we would factor as if it was an equation, and we would use the solutions the same way. So first I'm going to notice that there's a 3 out in front, so I'm going to try, can I factor out the 3? 6 divides by 3, 45 divides by 3, so it does. And I'd be left with x squared plus 2x minus 15. Bring down the 3, split the quadratic part into its two factors. Minus means the signs are different, and I need two numbers that multiply to 15 and subtract to 2. I need it to be a positive 2. So 5 and 3 do the trick. I put the 5 with the plus because the plus sign's in front of the 2 as well, and a 3. So it means that my zeros would be at positive 3 and negative 5. Those would be my zeros, because zeros and solutions are the same numbers, just a different context. Okay, so 3 and negative 5 are the zeros of the function and the solution to the equation. All right, guys, see you next time.